Hello, 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 everybody. I hope you're all doing well. Root Beer here, looking at question number 2 on our 2019 Fryer paper. Rope is fed into a machine at a constant rate of 2 meters per second. The machine can be set to cut off one piece of rope every t seconds for various values of t. For example, if the machine is set to make one cut every 5 seconds, then 12 pieces of rope are cut off in 1 minute. Okay, 60 seconds in a minute, 60 divided by 5, yeah, that would be 12 pieces of rope are cut off in a minute. All right, so we've got 4 parts here. 2 light bulbs and then 2 written, just like question number 1 from last video. So, if the machine is set to make one cut every 8 seconds, how many pieces of rope are cut off in 10 minutes? Okay, so same sort of reasoning applies. How many seconds? Because we need to compare our times, and it's not the easiest thing to compare minutes and seconds. So we'll take 10 minutes and then 60 seconds per minute, and that'll be a total of 600 seconds. Okay, so now 600 seconds divided by 8 seconds per cut is going to be how many cuts? Well, if I divide 600 by 4, it'll be 150. Divide it by 2 again to make 8, it'll be 75. So we'll get 75 cuts, and that's going to be our final answer there. Okay? You're more than welcome to use a calculator. I try and use just my brain whenever I can. So we got 75 cuts there. B part, if the machine is set to make one cut every 3 seconds, what is the length of each piece of rope that is cut off? Okay, well, we know how fast the rope is going into the machine. And we know when we're going to make a cut, so 3 seconds, 2 meters per second. Okay, so we should get 3 seconds per cut times 2 meters of rope per second. So I'm lining it up this way, and the units are actually giving me a bit of a hint, because I need to get seconds out of here. And so we'll get 3 times 2, 6 meters per cut. So the length of each piece of rope, each cut of rope, is going to be 6 meters. Okay? So we're just sort of playing around with units and getting our calculations in order. Okay? So C part. If each piece of rope that is cut is 30 meters long, determine the number of cuts per minute the machine is set to make. Okay. So this is going to be a combination of things. If the piece of rope that's cut is 30 meters long, and we know it's being fed at 2 meters per second, I should be able to figure out how many cuts per second. And then we want to translate that into cuts per minute. Okay. So we know 30 meters per cut is 2 meters per second times, let's call it t. Okay, t seconds per cut. And we want to explain, we don't want whoever's marking them to say, what's this t? Where did t come from? So we'll say where t is number of seconds per cut. I mean, it is right there in my expression of the units, but we just want to make sure that we're understood. So we know 30 meters per cut, and then 2 times t, that's going to be 2t. The seconds, again, they sort of cancel each other out, and we're left with meters per cut. So 30 is 2t, so we get 15 equals t seconds per cut. But we don't want seconds per cut. This would probably get me 1 mark. I don't know exactly the marking scheme. This might be a 3-mark question, in which case maybe this gets me 2 marks. But we know, okay, 15 cuts, or 15 seconds per cut. But what do we want? We want number of cuts in a minute. Okay, so we know 1 minute is equal to 60 seconds. So 1 minute, how many cuts per second? Or how many, we get 15 seconds per cut. So that's really 60 seconds over 15 seconds per cut. And we sort of invert and multiply. So 1 cut per 15 seconds. And now again, the seconds units cancel out. 60 divided by 15 is 4, so we get 4 cuts in a minute. And there we go. And we've explained it. I mean, you'll notice I'm not using a whole lot of words. I'm just setting up very nice, clear sort of equations that sort of speak for themselves. 1 minute divided by 15 seconds per cut, and we just sort of rearrange. Okay? If you wanted to, you could set 160 seconds per minute, and then you'd have 4 cuts per minute at the end. It's, not that big a deal. This isn't like a physics competition, so you don't need to be super exact with the units. I find the units just help me sort of line up what equations I would want to set up. All right, and now, we're at the end already. D part here. If the machine is set to make 16 cuts per minute, determine the length of each piece of rope that is cut. Okay, I think we're sort of going backwards. In the last one, we knew how long each cut was, and then we got cuts per minute. Now we're going to go cuts per minute and figure out how long each piece of rope is. Okay, so I want to change things into cuts per second because they're telling me the rope is fed in at 2 meters per second. So let's find cuts per second. Okay. Or actually, seconds per cut is probably the best one. So I know it's 16 cuts per minute. So 16 now, we get 60 seconds, or 60, 16 cuts per minute. So that's 16 cuts in 1 minute. And 1 minute is 60 seconds. So now the minutes cancel out, and we're left with, I suppose we can divide by 4 on top and bottom, so 4 cuts per 15 seconds. Okay, so 4 cuts every 15 seconds. But I wanted seconds per cut. So we get 15 seconds per 4 cuts. Okay? This is sort of just a universal constant about the question we're talking about, so it's okay to flip it around. 15 seconds every 4 cuts, or 4 cuts every 15 seconds. They mean the same thing. Okay, rope is fed at 2 meters per second. So 2 meters per second times how quickly the cuts are being made. So we'll get 2 times 15, which is 30. Seconds cancel out, so we'll get 30 meters per 4 cuts. Now I want to know how much per 1 cut. So 30 divided by 4, that's going to be 7.5 meters per cut. And if you want to, you can put a little therefore statement. 7.5 meters is the length of rope for each piece cut. Okay, there we go. So it's sort of a nice little conversion almost. I would say if you want to be a bit more general, if it was T, what was it? Cuts per minute, right? So if we've got T cuts, well, let's not say T, let's say K. We used T earlier in the question. If you have T cuts per minute, that's the same as 60 over K seconds per cut. And then that'll be 120 multiplying top and bottom by 2 meters per second, or multiplying the top by 2 meters per second. So that'll be 120 by K meters per cut. This is sort of the general progression that we sort of found there. And if we needed to keep going, if there was an E part or an F part, I would probably sort of make this as a general rule. And so 120 over 16, you can even double check, is 7.5. Okay? But nobody's asking for this sort of thing. If you prove it, go right ahead. You know, if you say this is a general formula, here's why it works, then you're more than able to do C and D parts very quickly from there. But you don't need to. This is just a fun little observation I thought I'd share with you at the end of the question. And we are at the end of the question. Up next will be question number 3, so I'll see you for more of our Fryer next time.